This question is based on a question from Pure Book 1, Chapter 5, on straight lines. And it's a good question because it tests most of the skills that you need when you're using straight lines. We'll look at part A first. The best way to show that two gradients are equal is to convert both of the equations into the y equals mx plus c form. So we've now rewritten the second equation as y equals mx plus c, and so we can simply state that the gradients are the same and therefore it is parallel. So remember, this is a show that question, which means that you need to be very clear what's going on. So the working to convert the equation of L2 into y equals mx plus c is part of the marks, but the rest of the marks will go on the fact that you stated that the gradients are the same, and the fact that then you say that they are parallel. One thing you can check is, have you stated in the last line what they've asked you to show? And they've said show it is parallel. So that means you do need the word parallel at the last line. Part B is asking us to find a perpendicular line. Remember that perpendicular lines have a gradient which is -1 over the gradient of the line they are perpendicular to. So now we need to find C by using the information of what point it goes through. And we're going to get a fraction. That's fine. Please do leave it as a fraction, a top-heavy fraction. So now we can write down what the equation of L3 is. So in part C, we're finding the intersection of L2 and L3. Remember, they intersect when the y's on both lines are the same and the x's are both the same. So all we do is we simply say, if the y's are the same, that means that. So we solve that for x. And once we've found x, we can then substitute into one of those to find y. And the easiest one to use is L2. So we can now just write down the point where they intersect. So now we need to find the shortest distance between the two parallel lines. And to do that, we take note of the information that is beside the question in the book, which says that the shortest distance between two parallel lines is the perpendicular distance between them. This is a graph of L1 and L2 and the perpendicular with the points marked where they intersect. And as you can see, the perpendicular distance is going to be the shortest. But just to check that, let's go to a GeoGebra interactive. So in this interactive, it's actually telling us what the distance is between A and B as I move point B. As you can see, as I move point B away, so it's no longer perpendicular, the distance is getting bigger. As I make it more and more perpendicular, it becomes smaller and smaller. And then as I move away, it becomes bigger again. That does make sense, because if you look at that, what's happening is you're not moving directly to the second line, you're moving at a bit of a slant, at a diagonal. And so that means that you surely will take longer. So the rule is, when you're finding the shortest distance between two parallel lines, you're looking for a perpendicular line between them. Now we just have to find the distance between those 2 points, A and B, and that will give us the distance between the two lines.